Hello and welcome back to OmegaCodex. We have been talking about Azure DevOps pipelines in our previous videos. One crucial aspect of our CI/CD flows are triggers that help us automate these pipelines. If you have ever wondered how to automate your pipeline processes based on different events like code pushes or schedule times, triggers are behind its magic. We'll explore what triggers are, the different types available, and how they can significantly streamline our development process. Whether you are working with classic pipelines or YAML pipelines, these triggers are a crucial part of it. So let's get started. Based on the pipeline type, we can have different type of triggers. Most commonly used are continuous integration or CI trigger, and the other one is continuous deployment or CD triggers. CI triggers are set up on YAML pipelines or classic build pipelines. CD trigger is done on classic release pipelines. CD is also done in YAML pipelines, but then that trigger is the same which we consider as a CI trigger. Some other triggers are like comment triggers supported for GitHub repositories, schedule triggers to run your pipelines on a schedule, PR triggers when a PR is raised, pipeline triggers in YAML pipelines, and build completion triggers in classic build to trigger a pipeline upon completion of another pipeline. The behavior may be a bit different based on the repository type you are working with. So let's jump to Azure DevOps and start looking at them one by one. Let's use the same project which we were using in previous videos. So let's open a pipeline. So the first statement here is trigger, and we can see that here it is mentioned as trigger main. What this means is the pipeline would be triggered whenever there is a change pushed to the main branch. You could also define more branches here, like suppose we have releases and anything under releases. If there is a branch that has to be triggered, and this is like how you basically create triggers in a very simple manner. We can create more advanced triggers by using different properties. Like first one is branches. So branches has options include and exclude. So we can define include, and we can mention the same branches as we did earlier. This is equivalent, or rather what was mentioned earlier was equivalent to defining it in this way, that branches include these two branches. You can also add like reference tags. So you can have tags and stars. So if any new tags are created, that also gets included. There is also a different option, separate option to define tags as well, and tags also has include exclude options. But in tags you can straight away mention the tag name. Suppose I want anything which starts with release 1, and we can say that anything which starts with release 1 is included, for example. Now you also have exclude keyword, which is helpful in, for example, we want all branches under releases to be triggered by this pipeline, but anything which starts with say old, we want to exclude that. So this way you can also mention exclude property for your trigger. Another option you have is paths. It is helpful when, for example, you have defined your triggers for a particular branch, but you only want to trigger it when a certain section of your repository is changed. Say you have multiple projects in your solution, but you want to trigger it only when a certain part of the code or a certain project is changed. For others, maybe you have a different pipeline, you are triggering that. Say suppose you have a hypothetical scenario, like you have a web app and you have API, and you want to trigger different pipelines when web changes to web is made or changes to API is made. You want to trigger different pipelines. So this, using paths keyword, say for example, I would say that include web app. So for example, say here, if there is a change inside the web app folder, then only the pipeline is triggered. One more option you have is batch. So this helps you in batching your continuous integration runs. So for example, you have multiple people working on the repo, and if somebody pushes a change, the pipeline gets triggered. And when the pipeline is running, in the meantime, suppose say 2 more developers checked in their code. So ideally you would have 2 more continuous integration runs, but you can minimize the number of runs by combining it and batching it. If you mention batch as true, what it will do is it will straight away straight away do only a single run, including the changes of both the developers. So batch kind of helps you in minimizing the number of runs when multiple people are working on the repository. Now say you don't want to run the pipeline at all. So the default behavior of a YAML pipeline is that even if you don't define a trigger, it will run the pipeline if there is a change in the repo. So it would be something similar to defining as star, which is like run for all branches. So if you even don't define a trigger, it will run for all branches. So if you want to completely make it manual, just mention trigger as none, and then it becomes a manual pipeline. So you'll have to always run it manually. You can also put some keywords in your commit messages if you want to skip a continuous integration run at times. So you could what you could do is in your commit message you can mention as skip CI in square brackets, so like this, and it will skip the pipeline run even if the trigger conditions are satisfied. There are a few other keywords as well as displayed on the screen which you can use if you want to temporarily skip a pipeline run. So this you have to mention in the commit message when you are pushing the changes to the Azure Git repository. And this was with YAML pipeline. Similarly, you have options to set up triggers when you are working with classic pipelines. So here on classic pipelines, you have this trigger tab, and we have this option called enable continuous integration. If we enable it, it gives you the options to add branch filters as well as adding path filters. You have include, exclude both options available, and you can set up as we did it in the YAML pipeline. We also have the batch option here. So you can batch your changes when the build is in progress, and it's similar to what we saw in the YAML. If we disable it, then it is equivalent to trigger none. So it is not triggered whenever there is a change in your branch. This part is pretty much similar even if you are using Azure Git repositories or if you are using GitHub repositories, and the options are pretty much similar. And the next trigger which I want to talk about is PR triggers. So with Azure DevOps Git repositories, the way you enable PR triggers is by setting up branch policies. So I have talked about it in this particular video, and you can, if you want to know more in detail, you can check out that video where I have also mentioned about branch policies. But yeah, on a basic level, if you come to the branches in your repos and you select the branch where you want to set up the branch policy, and you can add a new build policy for build validation. Let's just examine the existing one. So you have to create a build policy. You have to select which pipeline to be run when a PR is created on this branch. You can mention the paths if you want to add any path filters. You can, if you have multiple paths, you can just mention the paths in comma separated. No, sorry, it's using the semicolon as the separator. And if you want to make it like an exclude condition, then you can prefix it with a not or an exclamation symbol, and it is treated as exclusion. So it's like an example here, like web app star. So any changes to this path is included, but any changes to the tests folder inside web app is excluded. And I think the order is significant. So based on that order, it gets applied. After that, whether the trigger has to be automatic or manual, that you can mention. Whether it is a policy requirement. So whenever a PR is created, whether you want this build to pass or just you want to run it. So if it's optional, then build failure will not block the pull request. If it is required, then the build has to pass, which is in most cases what we want. And then last is the build expiration. What it means is that if there is a change into the PR, does your previous build validation stays intact? So as selected here, immediately means as soon as there is a new change pushed to the PR, the previous build validation is considered invalid and it will run the build validation again. So if you want to have an expiration to it, so we can also do like after X number of hours, it is expired. So if there are consecutive changes, then probably the previous build validation is still considered. So this is how we do with Azure DevOps pipelines. If we are working with GitHub projects, not the Azure Git repositories, but repositories in GitHub, then it is slightly different. So this is a project which I have on GitHub. It's just a fork of some other sample. Here also we have this trigger with GitHub projects. What you can do is add PR, and using which you can set up PR triggers. Now, even if you don't define it, your PR trigger is automatically activated. So for any GitHub project, changes to any branch would or PR to any branch would trigger the pipeline. It's same as we were mentioning about the trigger keyword. So if you don't mention trigger, then your pipeline runs for pushes to any branches. Similarly, if you don't define PR keyword or you don't define PR in your YAML file, PR triggers, then it runs for any PRs created on your repository. But if you want to restrict to specific branches so that number of builds on your pipeline is reduced, then you can use the PR keyword, and it is same or similar as trigger. So you can mention in the same way like main, and you can define all the branches which you want to include. Same as trigger, we have branches option here, and branches as include and exclude, and you can mention it in this way also when you're defining the trigger. And you can use the exclude keyword if you want to exclude any particular branch. Another option you have is paths, which is similar to what we saw with triggers. You can also include the path this way. There are two different options here. One is auto cancel, which by default is always. So it is similar to the build validation expiration which we saw in the branch policy. So by auto cancel by default is true. So any changes to the PR will automatically cancel the build validation, automatically cancel the pipeline. But if you put it false, then it doesn't cancel it. Drafts is for draft PRs. So whether you want to run your pipelines for draft PRs or not, by default it is enabled. So even if you create a draft PR, your build pipeline runs. But if you want to disable it, you can set it to false and it will not run. With classic pipelines on GitHub repositories, the apply option looks a bit different. So you have this new option here called pull request validation. If you remember, we didn't see it in the classic editor for Azure Git repositories, but here you have this pull request validation, and you can enable the pull request validation. It offers you the branch filters. You can also add paths. You have an option also to build pull requests from forks of this repository. So if there is a pull request created from any fork of your repository, you can run this pipeline. And also you can you have an additional option saying requiring team members comment before building a pull request. So somebody has to put a comment to start building the pull request. And the next one I want to talk about is scheduled triggers. So if you have a classic pipeline, then you have this scheduled option and you can add a schedule. So you can mention when you want to run it, what time, you can mention the time zone, and you have the branch filters also available as part of this. Now, the only problem here is that you can only schedule it to be run once in a day on a particular time. Say if you want to run at a particular interval, or say every 3 hours, so you will have to manually set all the timings or all the schedules which you want to run. So I can have one to be run at 4, one to be run at 6, one to be run at 2, this way. So say if you want to run every hour, then you will need to have 24 schedules defined in this interface. There is no option to use cron expressions here. So this is the only way you can do it. You can use this option, only schedule builds if there is a change in the pipeline. So this is helpful. If you don't want to unnecessarily run the build at the schedule, you only run it if there is a change, otherwise you skip it. So you can enable this option and reduce the number of builds if you have multiple schedules defined. Now with YAML pipelines, it is a bit different. With YAML pipelines, you can mention schedules by putting the schedule keyword, and then you have the cron expression where you can define the cron expression like when you want to run this pipeline, and you can use the power of cron expressions to define schedules once a day, multiple times a day, in whatever configurations you want. Say you want to run every day, you can define the cron expression. It would run every day at 12 a.m. You can also define which branches you want to include. So it has similar include, exclude properties. We have batch option where you want to batch the schedules. And then there is always, which is whether you want to run always on the schedule or if you want to run only if there is a change. So like we had seen in the classic editor, you can also run the schedules only when there is a change. So if there is no change and if the schedule occurs, the pipeline will not run. And it's a Boolean field, so you can mention it as true or false. And if it's false, then it will only run when there is a change to the pipeline. The next one is pipeline triggers. So the pipeline triggers are the triggers which helps you run a pipeline on completion of another pipeline. So these are like pipeline completion triggers. So if you are working with YAML pipelines, you can use the resources keyword, and in that you have this option called as pipelines. So here you can mention the pipeline, you can just give it a name, previous build, and you have to mention the source. So here you have to mention the name of a pipeline which already exists. So let's say some pipeline. So let's maybe and then we can mention project if the pipeline is in a different project. If the pipeline which you are referring to is in the same project, then you don't need the project option. You can straight away say trigger and true. And if you want to apply branch filters, then you can under the trigger you can again set up the same similar filters like we were doing with the main trigger keyword. And here you will have include, exclude, and main. You can also have like you want to run by stages or you want to trigger by tags. You can also use those options. If you are working with classic pipelines, so in triggers, you have this option called as build completion trigger. And here you can select the triggering build and you can mention your branch filters for that triggering build. So whenever there is a push on those branches and or when the pipeline one was run based on these branch filters, then this build would be triggered. So that covers all the CI triggers. The last one I want to cover is the classic release pipeline triggers. Here when you come to a release pipeline, a release definition, you have this, we have to select an artifact based on which we will be running our deployment pipeline. So here you have the circle symbol like a lightning symbol, which is the continuous deployment trigger, and by default it is disabled, but you can enable it. So what this would do is as soon as the build is completed and an artifact is available, this would get automatically triggered. So this is very much good for continuous deployment. So as soon as you have something built, you are ready to deploy it to dev, just go ahead and deploy it to dev. So you don't have to come and manually trigger the release pipeline. Again, you can define branch filters here. So artifacts created from a specific branch that only will be deployed. When you enable this deployment trigger, you could have a situation that your PR builds are also deployed. So to restrict it so that only your main branch artifacts are deployed, you can set up the branch filter. It is same as what we saw in other interfaces. So you also have a pull request trigger, and if you want to have some specific based on the pull request, we can mention it here. Now, this is just to create the release. It doesn't mean that your artifact is going to be deployed onto the server resource where you want to deploy it. So the other condition which comes into play is this pre-deployment conditions. So by default, it is after release. So it is connected to the artifact. You enable the continuous deployment trigger and it should trigger these stages one by one. But you can also control it. Like here it is set for after release, and for both stages it is selected as after release. I could change this for Linux. I can change it to after stage, and I can select dev as the stage. So then it becomes sequential. You are deploying one after another. You can have pre-deployment approvals, which will kind of restrict the deployments. If you have higher environments, you can kind of control it with these approvals. You can also have artifact filters here. Say if you have multiple artifacts defined here, then you can put an artifact filter that on which filter you want the stage to be triggered. This is another one, trigger even when the selected stage is partially succeed. So if the previous stage was partially succeeded, whether we want to still go ahead with the deployment. So if you select this, then it would go ahead with the deployment. If we want to keep it manual, we can just select manual, and this stage has to be triggered manual. You don't want to get into automatic deployment, then you can choose this. Then also have some gates. You can check for some Azure policy compliance, invoke an Azure function, invoke a REST API, query Azure monitor alerts, query work items. So these are some gates which you can define, based on which also you can set up the triggers. In most of the cases, it's not used. It's pretty much done with what you can do with the above options. So in pre-deployment approvers, you can select the approvers who will be notified if there is a deployment pending on the stage. Yeah, so if you have more than one approvers, then you can select how the approval should happen, whether it's in any order they can approve, in the sequence which is mentioned, it has to be approved of, if any of them approves, it is considered as approved. Usually anyone is used. So say if you have multiple leads or managers or product owners from whom you need approvals, maybe in most cases it's like anyone approves and then it goes ahead, just reducing the bureaucracy you have. So that's deployment approvals. And you can also schedule releases, but this is similar to what you saw in classic editor. You have to define for each of the timings in a day when you want to run it. If you just want to run it once a day, you can just define the schedule. Similar option like only schedule if there is a change. So only if there is a new build available with respect to the previous run, then only the schedule runs. If you enable it, then it runs that way. You can add new timings. So if you want to run twice a day, you can choose a different timing and it runs 2 times a day. That's pretty much covers all the triggers which I wanted to address in this video. That's about triggers. Experiment with it and customize it as per your need. I hope you found this video helpful. If you did, please hit that like button, share it with your friends and colleagues. Share your thoughts and questions in the comment box below. And don't forget to subscribe for more insights. Have you used triggers in your projects? Feel free to share your experiences. You can follow me on Instagram and LinkedIn for updates and more contents just like this. Links are available in the description box below. Until next time, keep coding smart and keep innovating. Adios.